everyone. I'm Dr. Likha Chandran, working as an assistant professor in the Department of Chemistry at VNR VJIT. Before we start, I want all of you to look around your room for a few seconds. Can you identify any 5 objects made up of plastic? Maybe your water bottle, phone case, pen, keyboard, or a glass. Now, here is an interesting question to you. Are all these materials made actually of plastics, or there are some more fundamental? So, today's topic we are going to cover is polymers. And by the end of this lecture, you will understand why we often say all plastics are polymers, but all polymers are not plastic. We will explore what polymers are, how they are formed, their different classification, and why biodegradable polymers are becoming so important in today's world. So, let us start with the lecture. Imagine waking up in the morning. You brush your teeth using a toothbrush, wear clothes, use a mobile phone, sit on a chair, and drink water from a bottle. Do you know that all polymers are involved in every one of these activities? In fact, polymers are so common that we often fail to notice them. Even our own body, made up of proteins, DNA, and carbohydrates, which are natural polymers. So, as we think polymers are not just industrial material, they are a part of our life itself. Can anyone tell me one natural polymer found in our body? Yes, exactly as I said, protein and DNA. So, let us understand more deeper what do you mean by a polymer. Yes, let us think of a train. So, as a train consists of many coaches, yes, many coaches are connected together itself. And if a single coach represents a single unit and each unit is being made up of like repetition of these units. So the word or like the repetition of these units to form a long chain is happening, a long train. So polymer is also a long chain or large molecules. So where it comes from a Greek word poly meaning many and mer means unit. Therefore, a polymer is simply molecule made up of many repeating units. Now, what is actually a monomer? A monomer is a small molecule that is capable of joining with many simpler or similar molecules. So, just think of our blocks. When it is connected to a normal structure, right? We join the playing blocks with each other and make it as a polymer or like a monomer which can be connected. So, another example we can tell from a large scale or like a chain, a symbol chain which we wear daily. So that is again each beads of it is known as a monomer and the long chain with what we wear is known as a polymer. So now when we think or like tell how these monomers join together. Yes. So how these are joined together? These are joined or like the process by which the simple molecules or monomers combine together through a strong bond, which is covalent bond, is known as polymerization. So polymerization is the repeating or like is the reaction happening between the monomers to make it as a long chain. So when we think of polyethylene, we say that ethylene is the simple molecule or like monomeric unit, and when it is joined together, we write it as CH2 bond CH2, it will be going on. So this chain will give. So the simple molecule which joins together is known as a monomer. Yes, hope that is clear. And the process, it is like joining together, the linking of two different monomers or like adding of the monomers is known as, the reaction is known as a polymerization. When we tell about polymerization, the important point to come in mind is what is polymerization, like degree of polymerization, which is always abbreviated as like DP. That means the number of repeating units present in the polymer is known as degree of polymerization. So how many number of repeating units that is made is known as polymer or degree of polymerization. So usually the degree of polymerization, if the numbering units, different unit is like very high, we say that the polymer is very strong. and it is like highly used for industrial materials. If the number repeating unit is very small or like lesser, then we say that the polymer is weak or like less stable, and which will be used in the common household or like usual daily hold purposes. So this is all about polymers, monomer, and the reaction by which a monomer is made into a polymer, polymerization. So hope this part is clear to everyone. Now we'll go into next class or next topic. After learning about the polymers, monomers, and polymerization, now my question to you students is like, if I ask you to classify books in a library, how would you do it? Yes, how would you do it? Maybe by subject, author, language, or publication year. Yes. Similarly, polymers can also be classified in different ways depending on what property we are considering. Yes. So we can classify them based on their origin, structure, based on mode of reaction or polymerization, and based on the molecular forces. So each classification helps engineers or like people to get the right material what is needed for the specific application. For example, if we need a flexible material, we choose elastomers rather than a branched polymer or like rather than a fiber. So if we need heat resistance, we may choose thermosetting polymers. So natural, semi-synthetic, and like we have lot amount of varieties or like classification. So based on this, let us start with the origin. So when it is starting with the origin, natural polymers comes directly or like it can be classified in three different ways, like natural polymers, semi-synthetic, and synthetic polymers. So when we talk on natural polymers, it comes directly from the nature. For example, like whatever is there in our body, like proteins, which are unnatural polymers, starch from the potatoes, silk from the silkworms, cellulose from plants, all are natural polymers. Now when we think about synthetic polymers, which is like humans, like manufactured by the humans using chemical processes, mainly for the industrial applications. Yes, so they are like polystyrene, PVC, nylon, Teflon, all these things. Now, what do you mean by semi-synthetic? So semi-synthetic is like a natural polymer modified version, like it is a chemically modified natural polymer. For example, cellulose acetate, rayon, which we wear a semi-synthetic fiber. So we prefer, or like usually people prefer semi-synthetic polymer over the synthetic polymer because they can tailor the property or they can be modified. The properties can be modified according to the specific needs. So by this, based on origin, we can say that polymers can be classified into three varieties: natural polymers, synthetic, and semi-synthetic. Similarly, let us see or let us think three different road networks, right? So we can say we have three different roads. One is a straight highway representing a linear polymer, or like a highway with us like a side roads. Yes, then it will be like a branched polymer. And when we talk about many crosslinks, like an interconnected roads, yes, junctions and junctions interconnections, then we see that it is as a cross-linked polymer. So a linear polymer, and these classification, like as I specified based on the roads or given example as a based on the roads, the polymers are like classified on the based on structure, which are mean by linear polymer, branch polymer, as well as cross-linked or network polymer. So linear polymer means monomers which are arranged in a straight chain. That means all the monomers will be along a straight chain. It will be moving as like, I'm just writing for C, like only this, it will be C. For branch shape polymer, it will be like a branch will be there. Yes, like this. For cross-linked, it will be like highly linked with each other. So there is no chance for a breakage of the bond. So when we check with this, we can see that linear polymers are often flexible because they can be changed easily. And branch polymers, we say that they are having lower density. And cross-link polymers, when there is no more changes of like, we cannot even break the bonds, they are highly strong rigid and heat resistant. So for example is like bakelite. For linear polymers which is like flexible, we say that polyethylene is the best example for linear polymer. Same branch polymer, we can say low density polyethylene, which is again. And cross-linked we say bakelite, which is used for the switchboards, telephone compartments, or like any other this vulcanized rubber, melamine. All these are all this comes under cross-linked polymers. Yes, so based on origin we understood, based on structure we understood. Now let us see based on the polymerization mode, how it is. So now, like, imagine you are building a wall using bricks. Yes, if you keep on adding one after the bricks one after another without removing anything, what will happen? Yes, what will happen? Nothing. The answer is very simple. The wall grows simple, or like wall grows continuously. This is very simple to what happens in addition polymerization. So based on polymerization, we can classify polymers into two: addition polymerization and condensation polymerization. So in addition polymerization, monomers containing double bonds will be joining together repeatedly to form a polymer chain. That means C double bond C, when it is polymerized, like for example, yes, ethylene, when it is polymerized, we see that it gets on added up. Yes, the double bond will be dislocating and it will be getting added up. The monomers gets added up and we found it as like polyethylene. We say that it as a polyethylene. Yes, now in case there is no removal of any small products or any byproducts or anything with this addition polymerization, every atom present in the monomer becomes a part of the final polymer. Yes, this is, and for main example, like as I told, it's polyethylene, which we use in our carry bags, bottles, or like PVC, which is used in pipes, insulators, or like polystyrene, which is commonly used in packaging materials. Now, let us look at another situation. Suppose you are using or preparing a chain by joining two different components together. What will happen? Every time you make a connection, a small piece can be removed off. Yes. So for example, like when two molecules react, a small part of water gets eliminated. So what happens when two molecules are reacting? A small part is getting removed off. A small part. Let us example water or like CO2, anything. So a small part's getting removed off. So what is this? When in, and this is like two monomers or two different atoms, they are joining together or condensing together to remove off a small molecule, and the rest everything is getting added up. So in condensation, and that process is known as condensation. Simple example is raining. Yes, two clouds will be joining together, fully loaded clouds will be joining together, and you get removed as like water. The water gets removed off, right, as the form in the form of rain. So simple. Condensation. So in condensation polymerization, monomers reacts step by step and a small amount of molecule, a small molecule will be removed off. The small molecules can be like water, methanol, or like ammonia, or like carbon dioxide, anything that will be removed as a byproduct. So for example, we can say like bakelite or like nylon 66, which we use in our clothings or ropes for the hangs and all. Polyesters, which we use for particularly for the clothing, PET bottles, whatever you use. And bakelite, as I told, which is used in electrical switches. All this are examples or like formed by the condensation polymers or polymerization. So as I told now, the polymers can be easily classified on the basis of mode of polymerization, that is addition polymerization and condensation polymerization. Yes, so in addition polymerization, there is no byproduct formed, and whatever or how much ever monomers are added or combined, they will be throughout the polymer chain. Whereas in case of condensation polymerization, the length or the number of monomers added will be getting reduced. It may not be the same as the number of monomers. So small byproduct will be removed. By this, I hope that polymerization techniques, addition and condensation, which is very important topic for us, is understood by you people. Yes. Now, let us talk on or like when we classify the polymers based on molecular forces. Yes, particularly molecular forces. Till now we looked into origin, based on their structure, and based on their polymerization. Now, forces. Yes, what happens with the forces? Yes, particularly mechanical properties. So we see that some polymers are stretchy. Yes, we can classify very stretchy like a rubber band. Some are very strong like nylon. But some, no, when we heat, what will happen? It remains hard, but some becomes very soft. So these things are like, or this classification comes under the is classified based on the molecular forces. So how this molecular forces? Based on the molecular chains. Yes, when we write C bond C, the form or the force happening between this bond is the responsible factor for the classification or like differences in this. So let us understand. Imagine a classroom. Yes, if the students are like here randomly sitting very loosely and they are very easy to move around, they are like free to move around, right? So what will happen? They will be moving here and there. So even if anybody comes in, it will be like they can be easily occupying the places. So when this is happening, this means that there is a weak intermolecular force. On the other hand, if students hold hands tightly and form a strong network, what will happen? Can anybody come and push the people? Will they fall down? No, no. So this is because the polymers represent, or like polymers are with strong intermolecular forces of attraction. So based on molecular forces, polymers are classified into 4 different categories. One is elastomer, second one is fibers, third is thermoplastic, and fourth is thermosetting. So when we talk on elastomers, what is elastomer? They are weakly cross-linked polymers that can be stretched and then return to their original shape. For example, best example what we tell in our daily life is rubber band. When you stretch, it elongates, and when you release, it comes back into its original shape. Yes. So similar way, when we talk on fibers, what is that? It is a long, thin, thread-like polymer. So when you think of corn, sweet corn or like normal corn, you might have seen a thready-like structure around the peels, right? Before we take the corn, there will be a thready-like structure. That are known as fibers. They are very long and highly rigid. They cannot be stretched, but they are long enough. So, for example, like nylon 66 is such a material. And when we tell on thermoplastic, what happens with thermoplastic is they are like slightly arranged or slightly branched, and when we heat, they can be molded. They start softening themselves, but as soon as it cooled, it will be cooled down. So the plastic material which can be heated, which can be softened on heating and is like lightly linear or slightly branched, is known as thermoplastic. Best example what we can say is like PVC or like polyethylene, what we see in our daily life. Next is thermosetting. As we told, thermosetting material, no? Since the bond, intermolecular force of attraction is very strong between them, they are highly cross-linked. So cross-link comes means it cannot be broken. So nothing can be changed over it. Neither it can be remolded also. So in that case, it is very strong. It cannot be changed. It cannot be, even though it is heated, it cannot be softened. So they are heavily cross-linked. So such materials are like, for example, we can say bakelite or as epoxy resins. Yes. So these are the properties, or these are the classification based on the molecular forces. For example, elastomers, fibers, thermoplastic, thermosetting plastics. Now, when we say another major important classification is based on the tacticity, that is arrangement of the side groups. How? Let us imagine that all of you are sitting in a row and each person, yes, is holding a flag. What will happen? The arrangement of these flags can influence how organized the row looks. Yes, if all of you are like arranged, all the flags are in a same line, then we say that that is like highly arranged. Yes, so this arrangement of the side groups or like flags gives the property or structure of the polymer. So according to this, or this property is known as tacticity for the polymer. The first property, or the first one when we say on tacticity, is isostatic polymer. So what happens in isostatic polymer? In isotactic polymer, all the side groups are arranged on the same side of the polymer chain. This regular arrangement allows the polymer, allows the polymer to, or the monomers in that to be closely packed together, which results in higher crystallinity. So when the polymer is like highly crystalline, so there will be like highly packing. So when it is highly crystalline, the greater strength and higher melting temperature will be seen. So that is isostatic, when all the side groups are arranged in the one line. Second type is symbiotic polymer. Here the side groups alternate, or like alternate from the regular, from one side to another side. This arrangement is also orderly and provides good crystallinity, but also with the good mechanical property. And the third type is atatic, where the side groups are arranged randomly along the chain. So because of this irregular arrangement, the chains cannot pack efficiently. So atatic polymers usually have low crystallinity and generally softer material, which is easy to break. So if I ask you a question like, can the arrangements be ordered? Yes. So, or like which arrangement is like highly organized? The answer should be isostatic or symbiotic polymers, whereas atatic polymers are comparatively less organized. Isostatic is highly ordered, symbiotic is less ordered, and atatic is least ordered arrangement. Yes. So I hope the classification for this is like clear. The classification can be made based on origin. In the origin, there are three types of classification. First one is natural, synthetic, and semi-synthetic. Next is based on the structure. We have linear, branched, and cross-linked or 3D network. And based on polymerization, we have two types of classification: addition polymerization and condensation polymerization. Based on molecular forces, we have three main types like elastomers, fibers, and plastic, where plastic can be reclassified into two types: thermoplastic and thermosetting. And based on tacticity, which is three types: isostatic, symbiotic, and atatic polymers. So in this class, we came to know about polymer, monomer, and polymerization with different classification of the polymers. I hope the class was fine and understood for you people. And we'll continue with the next lecture in the coming session. Thank you.